Yes. So today we are talking about the ideal gas law. And I want to go ahead and start with a quick review of some of the concepts and variables that we've talked about in the weeks before spring break. So our topic today is the ideal gas law. And so let's start by looking at our variables. We start with P, which is pressure. And we've talked in the past about 3 different units that we use for pressure. The first one that we mentioned is pascals. Okay, pascals is one of our units of measurement for pressure. Then we have PSI, which is pounds per square inch. And then our last unit of pressure is atmospheres. And remember that as long as we are working in chemistry, we will be looking for atmospheres. If you have a problem that is in a different unit, we must convert to atmospheres, okay? After pressure, then we have our units for volume. Okay, V equals volume in our equations. And we talked about volume in terms of centimeters cubed. And to convert from centimeters cubed to liters, we are going to divide by 100. We talked about centiliters, and to go from centiliters to liters, we're going to divide by 100. We talked about milliliters to liters, where we divide by 1,000. And then the unit that we are always and forever looking for is our liters. And the last one that we had gone over before we left for spring break was our temperature. Now, temperature has 3 units. When we're looking at temperature, we are looking at degrees Celsius, degrees Fahrenheit, and Kelvin. Okay, Kelvin is the temperature that we will always and forever be trying to look for. Now today we're going to introduce 2 new variables. So those 2 new variables that we're going to talk about today are lowercase n. And if you remember from stoichiometry, lowercase n is equal to moles. Okay, so n is going to represent the moles of the gas in the equation. Lowercase n is for moles. Okay, R is the gas constant. Okay, this number will always be the same. That's what constant means. It will always be the same. So if you have R in your equation, that number R is going to be the same forever and ever. Amen. Okay? So our gas constant is 0.082. Okay, Ms. Brown likes us to go to 2 decimal points. Yes, she does. But when we are working with the gas constant, we will be going to 3 decimal places. So 0.082. Okay, let's go ahead and start putting these pieces together. So we're going to start with an example that does not require for us to do any conversions. We'll start with a really, really easy example. And then we'll go ahead and move on to something that's a little bit more complicated, okay? So let's go back and talk real quick about the ideal gas law. our equation for the ideal gas law, there's always an equation that we have to follow. Our equation for the ideal gas law is PV equals nRT. Okay? Pressure times volume is equal to moles times the gas constant times the temperature. Okay? Now this is called the ideal gas law because it pertains to the perfect gas. Okay? This is how gases are supposed to behave. Okay? Doesn't mean that they follow the rules all the time. And we learn that a lot in science. There are rules and laws, but they are not always followed. So your ideal gas law is how they are supposed to behave, not necessarily how they actually are behaving. So let's start with a really simple problem. And I will give you this example. 1 atmosphere of chlorine gas has a volume of 7.5 liters. At STP, what is the number of moles present? Okay, so let's break this down really quick. I want to make sure I have all my variables. So if I look at P, do I have pressure? Okay, pressure, I should have atmospheres. I go back and I look. I have 1 atmosphere right here. I've got pressure. Volume, okay, I should be looking for liters. I go back and look at my problem. Liters is right here. Do I have moles? Okay, what is the number of moles? That tells me that I'm looking for moles. Okay, this is what I'm looking for in this problem. And then R. Wait a minute. I don't have to look for R. R is forever and ever going to be 0.082. Okay, then I look at T. Do I have a temperature? Okay, STP, if we remember from before spring break, stands for standard temperature and pressure, which is 1 atmosphere and 273 degrees, I'm sorry, not degrees, 273 Kelvin. Sorry guys, I've only had 1 cup of coffee today. So I officially have all of the variables that I need to figure out this problem. Okay, so I'm going to figure it out right here. We've got a little bit of space left. And so let's go ahead and work on getting this done. So my pressure is 1 atmosphere. Remember, if we don't have units on our numbers, they don't mean anything. Our volume is 7.5 liters equals, N is my unknown. Okay, I'm solving for X. R is 0.082 and my temperature is 273 Kelvin. Okay, now the cool thing is that once you figured out your variables, the rest of it is math. And math is easy. So let's go ahead and use our calculators on our phones. We're not trying to be fancy. Okay, 1 times 7.5, guess what it is? 7.5 equals. Now this is where I have to do real math. 0.082 times 273 is 22.386x. Miss Brown, why are you using 3 decimal places? Because my R, my gas constant has 3 decimal places, so I have to maintain the 3 decimal places. Okay? Starting with the ideal gas law, we will be adding in that extra decimal place. Okay? Now I have to isolate my X. So I divide both sides. by 22.386. And my answer for X, clear, come on, 2.5 divided by 22.386 equals 2.335. Okay, now 0.335 is what my variable is for N. That's my number that equals N. N means moles. So a complete answer should be 0.335 moles. Okay, so what I want y'all to do is this. Watch this video. Make sure that you understand. If you don't understand, go ahead and send me in the Google assignment any questions that you have. Do you want me to do some more examples? Are you good with this and you're ready to do the work? Whichever one it is, let me know. And remember that you can get a hold of me on Google Classroom or on the number that I posted in the Google Classroom announcement last week. So thanks so much, guys. Stay safe, stay home, and we will see you soon.